I want to talk about a different aspect of impulse today than we have been over the last several days. We alluded to this the day that we did our egg drop activity, but only briefly so that the egg drop activity would make a little bit more sense to you. We define impulse as the change in momentum experienced by something. There are two situations that can be explained really well by impulse, by that change in momentum. The first situation is when we have an object that is stopping, like maybe a baseball that we're catching, maybe a car that's stopping, whether it hits a cement wall or whether it stops at a stop sign. Maybe it's the basketball that I catch. Okay, maybe it's my head as it hits either the airbag or the steering wheel. When we're stopping an object, we have what I call a predetermined impulse. That means an impulse that's going to be the same no matter how I stop or no matter how that object stops. When I jump off a desk, and I think I showed you this the other day when we were doing the egg drop experiment, as I jump off a desk, I bend my legs. I bend my legs not to change the impulse that I experience. My impulse is going to be the same whether I bend my legs or not. When a car comes to a stop, we hope that that car comes to a gradual stop at a stop sign, but regardless of whether it does or not, its impulse will be exactly the same. Cars have crumple zones. You ever know that cars are designed to be destroyed in the case of a crash? Not so you have to buy a new car, but to keep you safe in the event of a crash. Regardless, though, of whether it has a crumple zone or not, the impulse experienced by the car would be exactly the same, no matter how it comes to a stop. The baseball, as I catch it, would be the impulse would be exactly the same, no matter how it comes to a stop. That's what we call a predetermined impulse. If the momentum of the object is 10 when it's moving, and then it's 0 sometime later, the impulse will be negative 10. It is not impulse that hurts me. Yeah, I'm traveling in an airplane at 800 kilometers per hour. It weighs, I don't know how many tons. Its momentum is massive. There is one thing that I'm certain of. The momentum of that airplane will at some point be 0. The impulse that I will experience, that airplane will experience, is we know exactly what it's going to be. It's the 0 final momentum minus the initial momentum, whatever it had when it was up in the sky. What we don't know is how that airplane is going to come to a stop. We hope it comes to a stop the way that it's supposed to, but it may not. It may come to a crashing stop. Regardless, the impulse experienced by that airplane will be exactly the same. Typically, what we want to do in that situation when we have a predetermined impulse is increase the time that it takes to stop. You better hope that your airplane takes a while to stop. It seems like they stop pretty quick on the runway, right? Like with those reverse thrusters, but it still takes quite a distance, several hundred meters to actually bring that airplane to a stop. You hope that your head stops against an airbag in the event of a crash as opposed to against the steering wheel. You hope that you increase the stopping time of your head. You hope that you're not even involved in the crash to begin with. You hope that your car comes to a gradual stop at a stoplight versus coming crashing into a concrete wall. Regardless, the impulse will be the same. The idea when the impulse is the same is typically to increase that stopping time. And when we increase that stopping time, the effect that that has is to decrease the force. We would say that force and time are inversely related to each other here. Time affects force. Time doesn't affect impulse. The impulse is predetermined. Time affects force inversely. As time goes up, force goes down. I suppose there's probably situations where maybe you want to maximize the force. If you wanted to maximize the force, what would you do to the time? Make it shorter, right? Smaller stopping time, although that's not usual, right? This is one of the basic principles behind every single thing in the world that cushions an impact. There are sometimes other principles involved as well, but this is one of them involved in everything, from the airbag to the crumple zone of the car, to the bending the knees when you jump off the desk, to the foam inside of a football helmet or a hockey helmet. It's designed to increase the stopping time to decrease the force. Now, I mentioned this briefly the other day. Does anybody remember what the other thing is for certain impact cushioning devices, like say a football helmet or a hockey helmet? Once we reduce the force by increasing the stopping time, yeah, the surface area spreads that force over your entire head as opposed to just in one spot on your head. So we decrease the force first, and then we spread that force over a bigger surface area, which lessens the impact on any one spot. It's the first principle that we really care about right now, though. That's what we're looking at, is increasing the stopping time, decreasing the force. Now, the other situation that can be explained really well by impulse is the exact opposite. When we don't have a predetermined impulse, it's what I call, I don't even know if this is a word or not, but since I make the notes, I get to choose whether it's a word or not. I'm going to call it a non-predetermined impulse. This is not when we're stopping an object, like a hockey puck or a baseball or a car, but rather when we're starting an object. Now, I'm going to make a little note of this. It doesn't necessarily mean we're starting it from rest. So we'll say not necessarily from rest. If I hit a golf ball off a tee, it's starting from rest. The impulse is not predetermined. If I hit a baseball that's coming towards me, I'm starting it moving in the other direction, but not from rest. And regardless of whether I started from rest or not, it's not a predetermined impulse. I control how much impulse I give to it. I control how much momentum it's going to have. Right now, the golf ball has 0 as it sits on the tee. How much is it going to have after I hit it? Well, that depends on a couple of factors. It's not predetermined. What 2 factors do you think would control how much impulse I give to that golf ball or that baseball or whatever it is that I'm trying to get moving? The force, right? If you want to make the impulse more, which typically you do, then you want to hit it harder. You want to maximize that force. If you increase the force, then the impulse goes up. Impulse and force are related to each other. In the last one, they weren't, right? The impulse was the same no matter what. No matter what happened to the force and time, the impulse stayed the same. Now, impulse and force are related to each other. Increase force, increase impulse. That's why when you see guys in Major League Baseball hitting home runs, like it's typically big, strong guys, big, strong players, right? Like this doesn't mean that small people can't hit home runs, but they don't hit 50 of them in a year, right? It's big guys that hit home runs because strength matters. The amount of force you apply matters. But there's a lot of guys that are really, really strong and are terrible hitters. What else do you have to have in addition to being really, really strong and applying a big force? Sorry? Accuracy, speed, like speed of bat speed, you mean? Yeah, but that comes down to force, right? Faster you swing the bat, the more force you apply on the ball. Skill, okay. Skill, you're getting closer here. Like time of impact. Yeah, like what it comes down to is form. When I go to hit a baseball, I'm not going to watch the ball. Oh, here comes the ball, and then stop right there. Because the ball is not going to go as far. Because I'm not going to apply as much. I'm not going to give it as much impulse. Why not? Because the ball's not in contact with the bat for as long. If I'm hitting a golf ball, I don't just do this and then stop right here. I follow through, right? I follow through. Good golfers can hit the ball hard, but they also have good form so that they follow through. And the follow through is what allows more time of contact. Here, force and time aren't related to each other like they were back here. Here, Force is related to impulse, as is time related to impulse. Increase force, increase impulse. Increase time of contact, increase impulse. Make sense? All right, we're going to take a few minutes right now at your desks to work on check and reflect questions on page 467 of your textbook that you can get from Google Classroom under the About tab, Chapter 9, questions 1 to 13. You're not going to have the rest of the class to work on this, but we'll give you probably 10, 15 minutes to get a good head start on them so you don't have quite as many questions for homework tonight.